Hi, my name is Choi Ho-kyun, and this week we will study about bipolar junction transistors. Let's start class. Bipolar junction transistor mean two type of PN junction, like this way, and use this junction part to transport carrier to flow current. This is kind of BJT, bipolar junction transistor. This is NPN transistor, and this one is PNP transistor. And the important part of this transistor is emitter and base and collector. This emitter is act like source at FAT, field effect transistor, and this base act like channel, and collector is acting like drain at the FAT. FET is control gate, is capacitively coupled to the channel, and BJT is direct connection to flow so many current. And the difference of this FET and BJT is FET use drift current and BJT use diffusion current. This is operation of BJT. In case of NPN transistor, some electrons is emitting from these emitter parts to transport collector. So the current is negative sign compared with the electron, so current flow right to left, and PNP is opposite case. And this transistor we can apply carrier of voltage low and carrier of current low, so emitter current equal the collector current plus base current, and this base current is very small value. And this is the operation of BJT. We apply this emitter base part, we apply this part to forward bias, and base collector part we apply reverse bias. So the energy level is lower than original energy band diagram, so carriers easily transport emitter to collector. And we define current gain alpha is collector current over emitter current. And before we thinking about the emitter current equal collector current plus base current, so we can think this alpha is smaller than 1. Also, this is BJT operation. And this part we can see the BJT mode of operation. We apply reverse bias at NP, this emitter base part, emitter base junction. We can easily call this junction EB J, and this part we can call CBJ. So we apply reverse bias at EBJ and reverse bias also CBJ. We can, this mode is cutoff mode, and for the reverse case we can call this is active mode, and usually we don't use this mode. And final mode is forward voltage saturation mode. And the FAT, this is difference of BJT and FET. This picture is real BJT pictures. This is common base and common emitter. Common means ground, so the first picture means the base is grounded. Then the collector current will be act like this graph, and this is, we put emitter grounded, then we can see collector current will flow this like this. This is the same picture. This picture is with the case that we use BJT act like digital circuit. We apply the zero bias of VCC, then the current will be 1. So we input 0 and the output will be 1, and we apply the bias 1 and the current will be 0. That means this BJT acts like some inverter. So we define this is digital circuit, and this is the using way of analog circuit. We input the base current, some AC signal, then the output collector current and some VCE will be amplified through this BJT. If we use BJT act like some emitter, we can see the Miller effect, and at this some transistor. Miller effect means if we input the input voltage, and we amplified this voltage, and the output is V out, then some load capacitance will be amplified, then compare then input impedance, input capacitance. So we use the circuit like high pass filter or low pass filter. This is the same things, and we can think about this energy band diagram of BJT, and we separate the current part, some emitter part, and some collector current over emitter current, and collector current, and electron. How many electron flows, and this part is injection efficiency. This gamma equal electron move at emitter to base, and this is the whole part. This mean some electron and holes we think both of currents. So we want to better than before. We can doping much more heavily than the base. That means if we doping more than the base, and some carriers is more than before, so we can higher efficiency about this way. And collection efficiency, this efficiency is mean some base to collector part. If we want to greater than the 1, we can apply the reverse voltage higher, then this hole will be easily moving this way, so we can higher this collection efficiency. And transport efficiency is mean how well this base will transport emitter to current. And this part at the base, some electron and holes recombination and reduce the diffusion current, so we define this transport efficiency is 1 minus I recombination over I and E. So we want alpha T higher, and we can think we have to reduce this recombination current, so we reduce the length of base, so reduce the time this hole and electrons recombination. This is the same picture. And finally we define this current gain alpha is gamma, alpha T and M, product of these 3 variants. Thank you to listen this class. See you next week.